Next question on significant figure is calculate the proper significant figures. Means in the answer, how many significant figures should be there? And it is multiplication. The rule for multiplication is that the result will have the significant figures equal to the one number which has minimum significance.
Least, sir.
Here we have in both three. So three minimum significant figures. So if we multiply these two, we will get 141.12. But this has five significant figures. So we need to round it off in such a way that it has only three significant figures and the value is not too different. It has to remain close. It can't change. The correct answer will be 141 because it has three significant figures, although you get 141.12. So rule you applied of multiplication. If there is any confusion, you can ask. Okay. Now, next one, 108 divided by 7.2. Here you don't need to even calculation because the question is about calculate the proper significant figures. Question is about just significant figures. We are doing calculation just to find out whether there is any rounding off required or not. 108.7.2. How many significant figures in the answer? Only two.
Sir, 2.
Yes, correct. So it is division. In
Yes.
division and multiplication, you have to have only those many significant figures as there are in any figure with minimum significant numbers. Significant figures here only two. So if you divide, you will get 15. Remember, one very important point here. Whenever the calculation, multiplication, division is there and you have exact numbers, you won't consider exact number in finding the significant figures if decimals are there. So if decimals are there, exact numbers are not considered in that case. So in the answer, there will be only two. In this particular case, even if you consider here, this is three, you won't consider because minimum one, you will consider two here. So 15 will be the correct answer. 15 has two significant numbers or significant figures. Similarly, in this one, if the question is how many significant figures should be present, you don't need to calculate. Remember, sometimes students start calculating and then give the answer. Question is about how many significant figures.
Sir, 3.
Yes, correct. Good. Okay. And yes, Yash Vedi, your answer correct. Good. Why three? Because this is multiplication division question. And the minimum number of significant figures are here. Only three. Because this zero is towards left, it will not be considered. Three significant figures will be there in the answer. So I'm just simply applying the rules. It means you need to remember the rules. Yes, your answers were correct. I'm just looking on the answers. Arna, Samad, Devyanshi, no, sorry, Devyansh Chavda, Lemuel, correct. Good. Now the question, how many significant figures should be present in the answer?
Sir, 1.
Okay, tell me in the chat box, everyone. Tell me in the chat box. Lemuel, no. Kavish, no. Samad, no. Yash Bedi, no. Devyansh, no. Ariman, correct. Tanu, correct. Shivani, correct. One more answer. Okay, Naman, Samad, Tanishi, now correct. Kartike, no. Kavish, no. Yash Bedi, yes. Shashwat, Chitej, Devansh, Pranav, correct. Okay, Arna, Gyanendra, Kartike, correct. Okay, don't respond to everyone. Devanshi, don't respond to everyone. Just select either to panelists or to me. Okay, or examining classes there. I told you in previous one here, exact number is not considered. In this, 5 is exact number. You won't consider 5. Okay. So there will be only 4 significant figures in the answer. This is the only one which will decide the significant figures, and this will have the minimum one only because there is only one. So again, leaving the exact number 5. How many significant figures should be there? Don't respond to everyone, just respond in the chat window. How many significant figures will be there as answer here? Yes. Survey, if you have responded to this one, correct. Yash, Arjun, Tanu, correct. Pratham, no. Lamal, Samat, Tanishi, Samat, correct. Devanshi, no. Yash, correct. Aryaman, no. Arna, no. Kartikeya, yes. Kavish, yes. Now, in this case, you will have to add. And the reason is, even if you don't add, right, there might be a possibility. I'll tell you why you need to add. Okay. So first of all, how many decimal places are there? Remember, in case of addition, in chemistry, the rule is different. It is minimum number of decimal figure. But in all decimal numbers are 4. Here also decimal digits 4, here 4, here 4. So in the answer, decimal digits must be 4, but significant figures can be different. In this case, although the answer will be 4, I'll tell you in what case it will be different. In this case, if I add 0.7864, 0.1, 0125, 61718, right? So it will be like this. So yes, there are only 4. But suppose this one is 8. Then what will happen? In that case, it will be 1.6204, and there are 5 significant figures, not 4. Answer will be decided only by how many decimal places will be there. Decimal places will be 4, but total significant figures in that case will be 5, because the question is about how many significant figures. So in such cases, you may need to add. Don't think that in addition, you can get the answer without adding or subtracting. Is
Sir,
that clear?
so at the right side of the decimal, sir, we have to round off till 3 digits, no, sir? Because there is 3 significant number as the least value.
4 decimal places, not significant number. In addition and subtraction, the rule is the result will have as many decimal places as there are minimum decimal places in any number.
Okay,
Minimum
sir.
all 4. So here
Okay, sir.
answer will have 4 decimal places. So this is something you have to write first so that you don't make mistake. In answer, we will not check the significant figures. We will check the decimal places in addition and subtraction. So that's why we will have 4 decimal places, but significant figures can be different because 8.0534 has 4 decimal places and 0.0534 has 4 decimal places, and 1123.5942. This also has 4 decimal places, but all of these have different significant figures. Here you have 5, here you have 3, here you have 8 significant figures. Yes, Samad. So in such cases, first add, then have decimal numbers equal to 4 or whatever the minimum are, and then see how many significant figures are there. Is that clear what I am saying? And this
Yes,
is
sir.
one mistake.
Yes, sir.
Good. Now the question, next question. The mass of a piece of paper is 0.02 gram and the mass of a solid substance and the piece of paper. So only piece of paper 0.02 grams. Then piece of paper plus solid substance, 20.036 grams. If the volume of solid is this much, calculate the density of the substance up to proper number of significant figures. So it is written proper number of significant figures. So solid substance you can get from these two. Mass of solid will be 20.036 minus mass of paper 0.02. Easy. Only paper weighs this much, paper plus solid this much. So if you subtract the weight of paper, you will get mass of solid. And here is the catch. Here, when you solve this one, you will get 63120.016. Okay, this is what you will get. But this is not the correct calculation. You will do the rules at every step. Here you have added. So because you have added, you will have as many decimal places as you have in the minimum one. So here
Sir,
you
so
have,
here the answer is 20.02.
I'm coming to that. I'm coming to that. Okay.
Okay.
I'm coming to that. Or first, let me ask you, just tell me what you think. Calculate and tell me the answer in chat window. Let me see what you think, what you all think, everyone.
Sir, are you asking the final answer or at
No,
this
no,
step, sir?
I'm just ask. You can tell me final answer also. If you think that
Okay,
you
sir.
know, you can tell me final answer also. Okay, now let me tell you the final answer. Somewhere you need to check. Pratham, the middle step is correct. Kavish, middle step is correct. Atman, middle step, rounding off is not correct. However, you have taken correctly how many decimal numbers should be there. Ashni, your final answer is correct. Tanishi, yes, this step is correct. Pranav, this step answer correct. Yes, Bedi, no, final answer is not correct. But Pranav, final answer not correct. Devyansh, this step correct. Kartikeya, your final answer is correct. Shashwat, keep trying. Arna, this step is correct. Shivani, think how many significant figures should be there in the final answer. Kavish, final answer correct. Samad, check how many. Yes, so round off, Shivani. If you know how many significant figures should be there, you should round it off. Arna, round off to correct significant figures. Final answer. Samad, round off to correct significant figures. No, Arjun, not only one. Okay, now see, and if you can understand this point, you will be able to answer, all such questions, whether asked directly or indirectly. This is asked indirectly. Okay, direct questions where calculation is given and you just need to give answer. Here in this case, the two quantities which you need to add or subtract, the minimum number of decimal places 2. It means answer will also have decimal places only 2. So 20.02. This is 6 greater than 5. So rule is very simple as you have done till 10th. You increase this by 1, add 1 here. So you got the mass of the solid as 20.02. And by the formula, that density of solid will be mass of solid divided by volume of solid. It will be 20.02 divided by 2.16. It is given. Okay. Now, when you solve this one, it will be somewhere 9.268, 9.268 and something. Okay. But when you see this, this is division, and division you will see the minimum number of significant figures, 3. So answer must have 3 significant figures only. It means you need to remove this 8. When you remove this 8, it will be 9.27. 8 removed, added 1 to 6 gram per ml. So every step you will apply rule where you are adding and dividing, there again you will apply rule on each step. So first there was subtraction, we applied rule of addition and subtraction here. Then there was division, we applied rule of multiplication and division here. If anyone has any confusion, don't hesitate to ask and tell me which step is not clear. Next question. Perform the following calculations and express the result to proper number of significant figures. So first, you will do under the brackets and multiplication. Calculations anyway will be as per BODMAS rule. So 2.54 multiplied by 8.4. So the result, this result will have 2 significant figures only because 8.4 has only 2 significant figures. So 2.54 8.4 so it will be 21.336. So you will write equals to 144.3 plus 21.336, but it should have only 2 significant figures. It means 21. It means it will be 165.3 meter square. Now remember again, here I have applied addition rule. In this addition, 21 is exact number. I will ignore this one. So result will have as many decimal places as there are in 144.3. Clear? Simple questions, but still chances of mistake if you miss any step. For every step, you will apply the rule. First, you applied rule here. Then you applied rule here. Remember in the answer, it won't be as per physics Only two significant figures? No. One decimal place will decide it. One decimal
Sir,
place.
so the exact numbers are not considered in either of sir multiplication, division, and addition, subtraction. Or
Yes,
sir,
exact numbers are not considered.
okay, sir, okay, sir.
Okay. Now the next one. First, tell me the answer. You solve it and tell me the answer first. Sabve Raj, calculation mistake. No, might be correct. Might be correct. So, yes, answer is correct. But keep the answer in standard form. Don't change the standard form. However, your answer is correct, sub. Okay, that is acceptable. Uh, Atman, when you subtract something from 4.05, it cannot be greater than 4.05. Naman, check your calculation. Devyansh, you have given me correct answer, but you have skipped the exponent part. Samat, calculation mistake. Yash Bedi, again you missed the exponent part.
Sir, I first missed the exponent part, but now I have given the correct one. Please.
Okay. Lemuel, correct. Okay. There are different answers, many different answers. Okay. In this case, I suggest that keep the answer in the exponent form if exponents are given. Okay. So I'm telling you that both answers are correct, but why this answer is preferred, what I am going to tell you. When you subtract, here exponent parts are same. It means you can directly subtract 0.0225 from 4.05. Okay. So it will be 5, 7, okay, 2, 0, 4.0275 into 10 to the power 2. This will be the answer. Yeah. But because it is subtraction, the answer will have minimum number of decimal places. Minimum number of decimal places are here. So it means it will be 4.03 into 10 to the power. Now there is another way. You can consider this one equals to 403 also, or sorry, this one as 402.75 also. So if you consider it as 402.75, it has two decimal places in that case. Okay. So in that case, that can be considered correct, but this is the answer because it is in exponent form. You need to keep it in exponent form.
सर
Yes.
सर बॉड मास के पहले मल्टीप्लिकेशन होना है
In standard forms, it's not multiplication. This is not multiplication. This is a standard form. So you won't disturb it. Okay. It is exponent form. You keep it in exponent form. For example, tell me if you have to subtract 0.6, sorry, 1.01 into 10 to the power minus 31 plus 0.023 into 10 to the power minus 31. Do you first multiply 10 to the power minus 31? Do you do that? You don't do that. You won't put 31 zeros, right?
Sir, we will add
Yes.
1.01 and the other number and
Yes,
keep
you,
the 10 at 10 to the power minus 62.
you will just add these two, 1.033, and you will keep the exponent as it is. So if
Okay,
it
sir.
is in standard form, exponential form, you don't simplify the exponent part. That's what I'm saying. That's why preference is to this. 10 power 2 will remain as it is. It is the exponent part. Okay. In any calculations, for example, if you have to do calculations like 2.02 into 10 to the power 5, and you multiply, for example, not division, etc., say 3 into 10 to the power 11, you don't simplify this one. You just multiply the coefficient parts, 6.06 and 10 to the power 16, 5 plus 11. That's what you do. So these are calculations in exponents. Is that clear? Why you don't need to multiply first? This is as per Bodmer's rule, but you don't simplify the exponents.
Sir, it's common. That is why.
Come again. It is.
So I was saying because it's common.
Yeah, that is common. You can take common. That's absolutely fine, but you don't simplify.
Sir, but what would happen if the exponents were different? So, like in this question, in one, and the like the exponents are very big, but the values are different. So, what would we
Yes,
do?
in that case, first you will make the exponents equal. Only then you can do subtraction and addition. If exponents are not same, you can't do addition subtraction. So you will
Yes,
have
sir.
to make it intelligently in such a way that you get the number of decimal places as you want.
So, sir, we can do it like multiply and divide by the same number to change the
No,
exponent, and
remember,
then
no. Suppose it is 3. Okay. Then you won't change this one because this is deciding how many decimal places will be there. This part will not be changed. The one which is deciding the number of decimal places in the answer. You will change this part and you will make it 10 power 2. So you will write it 4.05 into 10 power 2 minus 0.225 into 10 to the power 2. You made both the exponent parts equal, 10 power 2. Is that clear?
yes, sir.
And then you will do the calculations. This will still decide the number of decimal places in the answer. So that part will not be changed, which is deciding the number of decimal places in the answer. Next, tell me the answer of this one. This is multiplication only, nothing else. So now check the exponent part calculation 10 power 2 into 10 power 6. Devyansh, your answer is correct. There are two possible answers, but I'll tell you why there is better answer, Devyansh. And this is something I mentioned in the previous class also. Yash Bedi correct answer. Lemuel correct. Answer, all answers are correct, right? Same. But what I'm saying that you can write it in a better way. Amir, you have given the correct form also. So correct answer and correct form. Arjun, correct answer. Survey calculation mistake. Survey 10 power 2 into 10 power 6 will be 10 to the power 8. Pranav, correct. Lemuel, correct. Kavish, correct answer and correct form. Sankirti, correct answer, correct form. Kartike, calculation mistake. Tanishi, calculation mistake. It is not 2.5 into 4, Tanishi. It is 3.5 into 4. Kshitij, yes, correct. Tanu, Tanu, no, it has, first of all, it has four significant figures and 10 to the power 18 will not be there. Some other, no, now look here. When we multiply the coefficient parts together. When you multiply 3.5 into 435 into 4 is 140. So it will be 14. And when you multiply 10 to the power 2 and 10 power 6, it will be 10 to the power 8. And this answer is correct. Okay. Is this correct? Or this is wrong?
So it's correct.
It's correct. Okay. Now tell me. Now tell me. If you say,
Sir, there should be a point zero.
how many
Yes, sir.
significant
We
figures
have to consider the decimal points as well.
right? Okay, so that's why I said the form is not correct, although you got correct value, but the form was not correct. Okay, so here you need to have three significant figures. It is multiplication. So in multiplication, you need to have minimum number of significant figures. Here both have three. It means you need to have three significant figures here. So it will be 14. You can say 14.0 into 10 to the power 8. But still, this is not the best form. Now it is correct, but it is not best form. The best is a standard form, that is 1.40 into 10 to the power 9. I said a standard form is that the decimal is always after one digit, not after two digits or three digits. Although you won't lose marks here most probably. This is correct. But this is something, the value is correct, but answer is not correct. Value correct, wrong answer. This one, correct answer. Okay. Not in standard form. This one, correct answer. Correct form. Standard form. So you need to write it like 1.40 into 10 power 9. Although your teacher won't deduct marks, but you need to adopt best practices. Next part is laws of chemical combinations. There are in CBSE, there are 5 chemical laws of chemical combination. And one is more, which is specifically for JEE and NEET. The first one is law of conservation of mass, which you have done in your previous grades as well. Law of definite proportion, law of multiple proportion. This is the one from where most of the questions will appear. Fourth one, Gay-Lussac's law of gaseous volumes. And the fifth one, Avogadro law. The one which is specifically for JEE and NEET is law of reciprocal proportion. And it is not there in NCERT also. So you won't find it in NCERT, but this is in syllabus of JEE and NEET. First, I'll cover these 5. And After that, I'll cover this one. The law of conservation of mass is very simple, that mass remains constant. So if there is a reaction, A plus B gives you C plus 2D, or 3A plus B gives you C plus 2D, something like this. The mass before reaction and the mass after reaction will be same, exactly same. Okay. However, in few reactions where energy is involved, that energy has to be considered in terms of mass, but we are not going into those details. Your questions will be very simple. Mass on left hand side, mass on right side, nothing else. It means mass can neither be created nor destroyed. It will remain same. Second one, law of definite proportion. Definite proportion means that proportion percentage is constant, definite. So irrespective of source, a given compound always contains exactly the same proportion of element by weight. Means if I say calcium carbonate, whether I get it from the minerals, okay, or I prepare it in the laboratory. So whether I get it from natural sources or I prepare it in lab, in both cases, it will have exactly same. If I have 100 grams, 40 grams of calcium, 12 grams of carbon, and 48 grams of oxygen, irrespective of from where I have got. Although this is not 100% correct, but this is the rule you will remember. I'll tell you that why it is not 100% correct. Arjun, from CBSE perspective, as I said, that those reactions are out of syllabus. Okay, I just mentioned that don't get confused if somewhere you find it written that I didn't say nuclear reaction. I said the reactions where something is getting converted into energy. Okay. Mass, you know Einstein equation E equals to mc squared, right? You know that. So if you want to go into detail, you need to go into physics. That mass can be converted into energy. So if some mass can be converted to energy, that rule does not apply there, because you are just adding mass, you are not adding energy there. Okay? Mass equivalent of the energy. So that's why you might get confused. So in those cases only where mass is getting converted into energy, there might be some difference, but that is out of scope here in your syllabus. That is not in your syllabus. Is that clear, Arjun, what I'm saying?
Yes, sir.
Now, second rule is again very simple, that the proportion of the constituent elements will always be same. There is exception to this one, but for now, this is the rule. Third one and most important one, as I said, if two elements can combine to form more than one compound, the masses of one element that combine with the fixed mass of the other element are in the ratio of small whole numbers. Confused? Right? You won't get it anything. Okay. If you read it, just you might not be able to understand. Now try to understand what this rule says. This rule says that if you have two compounds of same elements, you have NO2 and you have nitric oxide, NO. So this is nitrogen dioxide. And this is nitric oxide. Both are made of nitrogen and oxygen. This rule says if you have fixed amount of any one, so suppose for simplicity, because here nitrogen seem to be equal, these are just one, means this is just 14 gram. If I say just 1 mole, suppose this is I'm considering 1 mole, and here also I'm considering 1 mole. So in 1 mole, this will be 14 gram. Oxygen will be 16 to the 32 grams. In nitric oxide, nitrogen 14 grams and oxygen 16 grams. This rule says that in such cases where two elements can combine, nitrogen and oxygen, for example, to form more than one compounds, that is NO2 and NO, then if we keep one element, mass of one element constant, 14 gram, 14 gram, then the masses of the other elements will be in simple whole ratio. Simple whole ratio or a small whole ratio, same thing. I'll explain again. Because by reading the definition, it will be difficult. Now, after understanding the example, if you go through the definition, you will be able to understand. I am giving you another example. Another example is H2O, H2O2, both 1 mole. In H2O, hydrogen is 2 into 1, 2 grams, because atomic mass of hydrogen is 1, and this one is 16 grams oxygen. In H2O2, again hydrogen 2 grams, but oxygen is again 32 grams. Keeping the mass of one element constant, 2 gram, 2 gram, the masses of other elements in simple whole ratio, 1:2. So if we fix the mass of one element, the ratio of the masses of other element will be a small whole number. Okay, ratio of a small whole numbers. This
Sir,
can be
how do
checked.
we fix the mass of other two elements, sir? That I'm unable
You
to
can,
understand.
you can anyone, right? Suppose you can fix, you want to fix mass of other element. You don't want to fix the mass of hydrogen. You want to fix the mass of oxygen. In that case, you will have to multiply this by 2. In water, 2 grams hydrogen combines with 16 gram of oxygen. It means 4 gram will combine with 32 gram of oxygen. Is that clear?
Sir, I understood. Sir, like the mass of one element must be same for
Yes.
both the compounds.
Yes. Now, in this case, you fix the mass of oxygen. Both are 32.
Yes, so now we
Then
have the ratio for hydrogen.
now you will have ratio for hydrogen. It will be
Yes,
4:2. That is 2:1. Again, simple whole ratio. So you can fix mass of anyone. The other ratio of masses will be simple whole ratio. Is that clear? Any confusion? Because this is the one which from where you will get most of the questions and numericals also. Okay. Another example, SO2, SO3. Mass of sulfur in 1 mole will be 32 grams in both, and oxygen here will be 16 to the 32 gram. Here 16 threes are 48 grams. The sulfur is constant. Ratio of masses of oxygen will be 32:48. That is 2:3. All the compounds where two elements combine to form more than one compounds, you will find this. Elements should be same. Sulfur, oxygen here, for example. So in both the compounds, elements will be same. You fix the mass of any one. The ratio of mass of the other one will be simple whole ratio. That's what the law of multiple proportion says. Now read it. If two elements can combine to form more than one compound, as I said, H2O and H2O2. The masses of one element that combine with fixed mass of other element. So masses of one element means we are talking about ratio of this one. When we have fixed the mass of other element, then the ratio of the masses of this element will be simple hole ratio. I would suggest that you memorize this definition. This question is very common, asked in your examination, that write the law of multiple proportion. So 3 marks question normally appears. A part will be write the law of multiple proportion, and B part will be a numerical based on this one that show that following figures follow the law of multiple proportion. So that is something you need to show, as I said, in case of H2O and H2O2, in case of NO2 and NO, in case of SO2 and SO3. There will be slightly typical numericals also. Those something I'll first solve here and then I'll ask you to do in assignments. First, let me know whether the rule is clear or not. Are you able to understand, or if there is any
Yes.
problem, which part is not clear? Good. Now next one. Gay-Lussac's law of gaseous volumes. This is the very simple rule. Okay. This rule says that if there are reactions where you have gaseous reactants and gaseous products, for example, N2 plus 3H2 will give you 2NH3. This is actually the commercial method of preparation of ammonia. It is known as Haber's process. In this case, nitrogen is gas, hydrogen is gas, ammonia is gas. So if gases combine or are produced in a chemical reaction, they do so in simple ratio by volume. And you know why? Because these are in simple ratio by mole. The molar ratio is 1 is to 3 is to 2. Is that clear? 1 is there, I have not written. 3, 2. So this is molar ratio. 1 is to 3 is to 2. And it is simple ratio. And you know that gases, if we talk about at STP, this will be 22.4, 1 into 22.4, this will be 3 into 22.4, this will be 2 into 22.4. It means it is in the ratio of their volume also. If you simplify this ratio, you divide by 22.4, you will again get same ratio. So in case of gases, molar ratio and volume ratios are same, because it is just a factor of 22.4. You need to multiply the moles to get the volume at STP. At any other temperature, this 22.4 might be different. Suppose the temperature is greater than 0 degrees Celsius, then this volume will increase. At higher temperature, gases will have higher volume. So it might be 25, but it will be 25 for everyone. So that will again get cancelled. So the rule is simple. If gases combine or are produced in a chemical reaction, they will always do so in simple whole ratio by volume. You need to keep the temperature and pressure constant, because the moment you change the temperature or pressure, the volume will change. So you need to consider all volumes at same temperature and pressure, whether it is STP or any other temperature or pressure, you need to keep that constant. Clear? Any confusion? Let me know before I move forward.
Sir, please explain once again.
Okay. This rule says that if any compound, say you have A plus 3B and these give you 2C plus and all are gases. Say this one is solid. This one is, suppose, for example. Then there will be simple ratio in the volumes of these three. And that ratio will be 1:3:2. Solids will not be considered, or gases, liquids will not be considered. Aqueous substances will not be considered, only gases will be considered. And the ratio of the volume will be actually the ratio of their moles, because you know 1 mole of the gas, if you convert into volume, if you remember that diagram, you need to multiply mole by 22.4. So whatever is the molar ratio, that will be the volumetric ratio. So at that time when Gay-Lussac proposed this law, nobody knew about that. But later on, we came to know that 1 mole of any gas at STP is 22.4 liters. Or we can say that at any constant temperature and pressure, 1 mole of all gases will have equal volume. So because there is direct relationship between mole and volume, so that's why I said if you have N2 plus 3H2 gives you 2NH3, here you have 1 mole, here you have 3 moles, and when they are consumed completely, how many moles of ammonia you get? 2 moles. Same will be the
Yes, sir.
volumetric ratio, that is 1 volume, 3 volume, 2 volumes of ammonia will be produced. Means if you have 1 liter of N2, 3 liters of hydrogen, you will get 2 liters of ammonia. So volumetric ratio will also be simple mole ratio. Is that clear?
Yes, sir. And it is always 1:3:2, sir.
In this case, yes. In this case, okay. If the reaction is different, then it will be different. So here it is 1:3:2 because here number of moles 1, 3, and 2. If this value is different, that will be different, but it will always be simple whole ratio.
Sir, so does this law represent the molar ratio itself, or sir, the ratio of the volume as well? Or
Both
sir,
are
only
same.
the
Both are same.
okay,
Both
sir.
will remain same. So whether you call it molar ratio or volumetric ratio, both are same because 1 mole is equal to 22.4 fixed value. So
Yes, sir.
2 moles will be 44.8.
Yes, sir. The ratio remains same.
Ratio will remain same.
Okay.
That's fine. But Gay-Lussac didn't say anything about mole. I told you about mole just to explain why it is so, because mole and volumes, those have a specific relationship. Those are proportional. Next is Avogadro law. And this one is again very simple. And this is because at that time nobody knew about that, but now you know about it. Equal volumes of gases at same temperature and pressure contain equal number of molecules. Now you know that because 22.4 liters of any gas at STP has 6.022 into 10 power 23 particles. These can be molecules, atoms, whatever. If gas is atomic, these will be atoms. If gas is molecule, these will be molecules. But in this much volume at STP, there will always be fixed ratio. It means if you have 11.2 liter of any gas at STP, say you have oxygen or you have hydrogen or you have nitrogen, 11.2 liter of any gas at STP will have half of it. Because here it is half, here also it will be half. It means equal volumes of gases at same temperature and pressure will have equal number of molecules. Is that clear?
Yes,
Because there is
Yes, sir.
direct relationship between volume and numbers. This can't be different. It is fixed relationship that 22.4 liter will have 6.022 into 10 power 23 molecules, irrespective of what gas we are talking about. Just memorize. Basically, you have been using this concept when we talked about mole. This is just how we put it in words, that equal volumes of gases at same temperature and pressure will have equal number of molecules. If 22.4 liter have this much, 1 liter will have 6.022 into 10 power 23 divided by 22.4 of all gases. So in that case, we don't bother about gas, and this is ideal condition. In reality, it does not happen, but what we are talking about, it is ideal condition. So whether it is CO2, carbon dioxide, whether it is ammonia, oxygen, nitrogen, methane, whatever gas, 1 liter will have 6.022 into 10 power 23 divided by 22.4 molecules or atoms. That's why we say that equal volumes will always have equal number of particles or molecules or atoms. So if you see in this reaction is just a depiction of H2 plus O2 gives you 2H2O. So if you write 2H2 plus O2 will give you 2H2O. Yeah. How you can write 2H2, 2H2, you can write H2 plus H2 plus O2 gives you 2H2O. Now what you see, here you have 1 mole, here you have 1 mole, here you have 1 mole, here you have 2 moles. And moles and volumes are directly related. It means this is 1 volume, this is 1 volume, this is 1 volume, this is 2 volume. In 1 volume, suppose you have 5 H2 molecules, 1, 2, 3, 4, 5. So this one also 1, 2, 3, 4, 5. So in 1 volume, you have equal 1, 2, 3, 4, 5. Now when they combine, so 1 H2 will combine with 1 O, 1 O, like this. Okay. So when they combine, they will have total 10 molecules. Number of atoms will be same. Number of hydrogen atoms, whatever we have on left hand side, we have total hydrogen atoms. If we see total hydrogen atoms, I am talking about, not molecules. 10 plus 10, 20 atoms. Okay. Here also we will have 20 atoms. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. If on left hand side we have 10 oxygen atoms, here also we will have 10 oxygen atoms on the right hand side. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But when they combine, they will combine in such a way that the equal volumes will have equal number of molecules. So this is 1 volume has how many molecules? 5. 1 volume, 5. 1 volume, 5 molecules. Here 2 volumes, 2H2O, you see 10 molecules. It means equal volumes have equal molecules. 1 volume will have 5, 2 volumes will have 10, 3 volumes will have 15, 4 volumes will have 20, like that. So this ratio will remain same. That's what Avogadro said. And this is obviously true, and it has to be true because atoms can neither be created nor destroyed. If they combine in such a manner that the number of atoms will remain same. They can't change. You just need to remember the definition. That is rather more important. Okay? If it is asked, Avogadro law explain that you can show this diagram and can show that 1 volume has 5 molecules and 2 volumes have 10 molecules. It means equal volumes have equal molecules as per unitary method. Then there is Dalton's atomic theory. Not very important, but still few questions appear from here. Matter consists of indivisible atoms. So Dalton was the first person who said that the smallest part atom and you can't further divide it. All the atoms of a given element have identical properties, including identical mass. However, this is not 100% correct. When I cover the exceptions, I'll tell you why. But I will still suggest that you go through the notes and memorize all these points. Okay. Just going through these points, you will not be able to memorize. Go through the notes and memorize.
So do
Atom
we need to take a note of these? So in a notebook, or we can take it from your website, sir?
from website you need to, okay. And as I said, I'm getting the PDF updated. The moment I get the updated PDF, I'll post it on the group also.
Okay,
Our
sir.
notes are available on website. Atoms of different elements differ in mass. Compounds are formed when atoms of different elements combine in fixed ratio. So Dalton was the first person who said atoms combine in a fixed ratio to form the compounds. Chemical reactions involve reorganization of atoms only. Okay. Atoms are neither created nor destroyed. So this is just reorganization, not creation or removal of the atoms. Dalton's theory could explain the laws of chemical combination, most of the laws, okay, but not all. Dalton's theory could explain the laws of chemical combination except the law of gaseous volumes and law of constant composition. When I talked about law of constant composition, I said that this is not 100% true. So I'll tell you why now.
Sir, this law of constant composition is same as law of constant proportion, or it's
Yes,
different?
yes, it is same.
Okay.
So it is written as both constant composition or constant proportion. Now, law of gaseous volumes, obviously, it does not talk about the volume. If you see here in Dalton's atomic theory, there is no mention of volume. So it does not explain the law of gaseous volumes, Gay-Lussac's law of gaseous volumes. Second one, law of constant composition, it does talk about. Okay, so it says that compounds are formed when atoms of different elements combine in fixed ratio. But there is something more about it. It also could not provide the reason for combining of atoms. So 3 points you will write where Dalton's theory failed. That it was not able to explain Gay-Lussac's law of gaseous volumes. It was not able to explain law of constant composition. And also it did not provide any reason of combining the atoms. Why atoms combine? It said that atoms combine, but why? It didn't talk about that. Now come to the question that in the law of constant composition, so it is related to the previous point. Is the law of constant composition true for all type of compounds? Explain why or why not. The law of constant composition says that irrespective of the source, whether I prepare it in lab or I get it from the atmosphere. The law of constant composition said that the carbon will always be say 12 gram, oxygen will be 16 into 232 grams, which is not correct. Because carbon has its own isotopes. Suppose one carbon here is C12, then it will be 12 gram. But suppose this one is C14, then this will be 14 gram. This one will be 32 gram. Now the composition is different. It is not constant proportion now. So why it is this statement is not true? Law of constant composition is not always true. The reason is there are isotopes of the elements. That's why it is not always true. So you will write the law of constant composition does not hold good when a compound is obtained by using different isotopes of the combining elements. It is true only for one type of isotope. So the law initially said that irrespective of the source, the masses of the or the composition of the elements is always same. So composition of elements will not be same if there are different isotopes of the same element. For example, in chlorine, yeah, in carbon dioxide, I explained. In chlorine also, 35 and 37, atomic mass 35, atomic mass 37, both can be present. What we use as 35.5 is average atomic mass. Okay. So carbon dioxide can be 12:32 ratio, carbon versus oxygen, or 14:, depending on whether we are talking about C12 or C14. Is that clear, everyone?
Yes, sir.
Or any
Yes, sir.
confusion? Okay. There should not be any confusion here.
Yes, sir.
Good. Which postulate of Dalton's theory was modified after the discovery of isotope? The same thing again, but it is now applicable to Dalton's theory also. According to postulate of Dalton's atomic theory, atoms of same element are identical in all respects. Second point, Dalton said all the atoms of a given element have identical properties, including identical mass. However, for isotopes, it is different. The atomic mass is different. Carbon 12, atomic mass 12 units, carbon 14, atomic mass 14 U. So this part of the Dalton's atomic theory was modified after discovery of isotopes. Okay. So however, after the discovery of isotopes, it was modified as atoms of same element may not be similar in all respects. These will be same for same type of isotopes of same element.